How can I tell if an atom is reactive? Let's review our Bohr model. First, we have our positive protons, followed by our neutral or no charge neutrons, and finally our negative electrons. Today we are going to be talking about our valence electrons that you learned about yesterday. So our valence electrons are the electrons that are in the last outer ring of the electron cloud. Go ahead and title your next 2 pages Reactivity. If you're in a regulars class, your next page numbers are going to be 14 and 15. If you're in a pre-AP class, your next 2 pages are going to be 12 and 13. Reactivity is a chemical property that determines how elements will react with other elements to form compounds. We can see how reactive an element is by looking at the element's group number. So in order to determine the group number, we need to look at the periodic table, and you should remember that the P in group can make that vertical arrow up and down. So go ahead and draw the boxes on the bottom of the page. Make sure you're drawing the table and make sure it has 3 rows and 8 columns. Take the time now to pause the video so that you can fill in each of the element squares. So you'll notice that our groups are up and down, so that each of these columns is one group. So do not draw this, but we're going to use this to look at the different valence electrons, which is what's going to determine our reactivity. So group 1, which is hydrogen, lithium, sodium, and everything down in group 1 has 1 valence electron. So you can see here, hydrogen has 1 in the last ring, lithium has 1, and sodium has 1. Moving on to group 2, beryllium and magnesium, and they have 2 valence electrons, which you can see here, 1, 2 in that outer ring, 1, 2 in the outer ring of magnesium as well. Next we move to group 13. So we jump over groups 3 through 12, which are in the middle of the periodic table that you will not use until you get to high school chemistry. So group 13 has that 3 valence electrons, just like boron, 1, 2, 3 in that outside ring, and aluminum, same thing, 1, 2, 3 in that outside ring. Let's move on to group 14. So group 14, we can expect it 4 valence electrons, 1, 2, 3, 4, just like in carbon and in silicone. Group 15, you've guessed it, 5 valence electrons. You can count them here, 1, 2, 3, 4, 5. Group 16 with 6 valence electrons. Group 17 with 7 valence electrons. And group 18 with 8 valence electrons. The only difference or exception is helium. As you can see, helium has 2 valence electrons in its outer shell, but the rest of the rows below it all have 8. So there's my little exception. So because of this, we know that group 1 and group 17 are my most reactive, and group 18 is my least reactive. This is because if you look at my group 1, they only have 1 valence electron, and all atoms want a full shell. So hydrogen and helium both want to have 2 electrons in that valence shell. Hydrogen only has 1, so it's extremely reactive because it wants 1 more. Lithium only has 1, and lithium wants 7 more. If you go to group 17 over here, group 17 has 7 valence electrons in their outer shell. All they need is 1 more to make a complete shell. So let's put it this way. All of the atoms want to have a full shell, just like everybody in group 18. So that's what makes group 18 the least reactive. They have their shells full. They don't need to share electrons with anybody. So we call these group numbers, and they're on the top of the periodic table. Many times you're going to see them as 1A, 2A, 3A, and so on and so forth across the top of the periodic table. So our groups are vertical columns on the periodic table, meaning they go up and down just like columns. Our groups identify the valence electrons, as you've seen from the bottom here. Group 1, 1, Group 2, 2, Group 13, 3, 14, 4, and so on. So the valence electrons determine how reactive. If you're Group 1 or Group 17, you're extremely reactive. If you're Group 2 or Group 16, you're still reactive, but not as much as Group 17 and Group 1. That's why these are in red. If you're Group 18, you're really not reactive at all. You're pretty calm. You have a full shell, don't need to share electrons with anybody.